America is facing a water crisis. It is here now, and urgent measures are imperative and the need for action is pressing. Is it time to panic? Well, that depends on what you plan to do about it. The world's growing population and the effects of climate change are fueling a heightened demand for freshwater resources. Climate change is playing a pivotal role in altering precipitation patterns and raising temperatures, leading to unexpected ice cap melts and a subsequent rise in sea levels. These changes bring about saltwater intrusion, frequent droughts, floods, and lack of water. With 71% of the earth covered with water, only 3% is fresh water. 2.5% of the earth's water is unavailable because it's locked up in glaciers, is highly polluted, or lies too far under the earth's surface. That being said, only 0.5% is available for us to use. Daily domestic water consumption in the United States accounts for 26,560 million gallons per day, of which 88% is supplied by centralized public services. Given America's substantial dependence on public water systems, it becomes essential to delve deeper into examining alternative approaches for ensuring water sustainability, as centralized water supply systems are often ill-suited for sustainable rainwater management. They disrupt natural water cycles and demand significant energy inputs. How can you help? The answer may be simple: rainwater harvesting. This project aims to investigate the practicality of adopting rainwater harvesting systems in residential contexts as an effective response to the water crisis. It underscores the imperative for its nationwide implementation in the United States. What is rainwater harvesting? Rainwater harvesting is a collection and storage of rainwater that runs off from rooftops, parks, roads, open grounds, etc. It is collected from a roof-like surface and redirected to a tank, cistern, deep pit, aquifer, or a reservoir with percolation, so that seeps down and restores the groundwater. Benefits include water conservation, decrease in your bills, lower demand on freshwater resources, slow erosion in dry environments, and it also reduces flooding in low-lying areas. Let's take a look at how to create the complete rainwater harvesting system.
Check roof surface is suitable for collecting quality rainwater. Install gutter mesh, such as Blue Mountain mesh, to prevent leaves and debris from blocking gutters. Fit gutter outlets from the underside of the gutter to prevent obstruction of water flow. Fit leaf eater or leaf beater rain heads to downpipes or downspouts to prevent blocking. Rain heads deflect leaves and debris and keep mosquitoes out of pipes that hold water. Install first flush diverters to help prevent the most contaminated rainwater from entering the tank. Ensure a tank screen is installed at tank entry point to keep mosquitoes and pests out. Consider annual rainfall, roof catchment area and water usage when determining the tank size. Attach insect-proof screens or flap valves to the end of all pipes to keep mosquitoes and pests out and ensure the tank is vented properly. Install an air gap to tank overflow outlets to prevent stormwater backflow into your tank. If required, utilise a tank top-up system or mains water switching device to automatically top up the tank with mains water when levels fall to a designated minimum level. If required, select a pump system to distribute water for use inside or outside the home. Fit a purpose-designed rainwater filter after the pump to help reduce residual sediment, colour and odour. Install a tank gauge water level indicator to your rainwater tank to monitor your water level and usage.
Rainwater harvesting systems ranges from uncomplicated to intricate, with options like rain barrels, above-ground tanks, and cisterns. This variation is based on various factors, including regional rainfall patterns, intended usage, household size, dwelling dimensions, and the location of the residence. Nonetheless, the fundamental elements of these remain consistent. To better advocate for the implementation of these systems, Feedback from community members, government officials, engineers, and healthcare professionals is crucial. A small-scale pilot rainwater harvesting system is set to be deployed at my home with the aim of gathering real-world data regarding its performance and feasibility. This test will look at cost, environmental effects, maintenance, rain patterns, city water use, location suitability, benefits, water quality, and how the water moves. In conclusion, the ultimate objective is to deliver measurable, objective, and evidence-backed data, encouraging policymakers to either mandate rainwater harvesting systems or to offer incentives for their adoption as standardized practices across the United States.